With the popularity of electric vehicles, a large number of EVs will become a burden to the future grid with arbitrary changing management. It is of vital significance to the control of EV charging and discharging state appropriately to enable the EVs to become friendly to the grid. Therefore, considering the potential of EVs seen as energy storage devices, the purpose of a multi-port DC to DC solid-state transformer topology for bidirectional PV battery-assisted EV parking load with vehicle-to-grid service and grid-to-vehicle service. Here, the major components we use are a grid and an electromechanical meter and a charging station, a car battery, a transformer, a switch, and scopes for displaying the battery results and V2G and G2V results. The main concept of this paper is here we use a bidirectional converter for charging the battery from the grid and to discharge the battery charge and transform into the grid. Here we use a electromechanical induction meter for measuring the voltage in terms of unit which is transformed from the grid and to the grid. And here we use a discrete signals as RGA, and here we use a switch for controlling the grid. When we enable the switch as 1, then grid to vehicle will start operating, and when we enable it to 0, then vehicle to grid will be operating. Here we use a subsystem, that's charging station. Opening this charging station, we can see another 5 subsystems like connection control, DC to AC converter, buck boost converter, DC to DC converter with battery controller, and battery switching control. Here you can see DC to AC converter. And a controller for this converter. Here you can see the MATLAB function. Here we use an IGBT as an universal bridge for converting the AC signal from the PV array to DC signal. And a buck boost controller is also used here, and the buck boost controller is also here. When the intensity of light increases and decreases, the voltage variation will also changes. To regulate that voltage, we used buck converter, and here we use a DC to DC converter with a battery controller, and inside that another subsystem is there, that is battery controller. You can see it is for controlling the battery state of charge, voltage and current. Here you can see the battery switching control for switching the operations from grid to vehicle and vehicle to grid. Actually, with the electrification in transportation system, EVs have developed rapidly in recent years. At the same time, with large-scale EV integration to power grids, the charging behavior of EVs bring both challenges and opportunities to power grid operation. First, the economic relationship between EV owners and the aggregator is studied. EV's owners and the aggregators' interest. Two multi-objective optimization methods are applied to investigate the economic relationship between these two stakeholders, and the aggregator owner economic inconsistency issue is presented. To mediate this issue, the results show that a significant reduction in the EV's owner's charging fee from the self-scheduling can be achieved while the aggregator profit is maximized.